Buenas tardes a todos y
Hello,
bienvenidos
good
a
afternoon,
una nueva
everyone, and
edición del
welcome
Becarios Knowledge
to
Day,
this
organizado
Becari's
por el
Knowledge
programa de
Day
becas de Economía de
organized
la Caixa y por la
by the
Asociación
La
de Becarios de
Caixa
esta misma
Foundation Grants
fundación.
Program
Digo buenas
and
tardes
this
porque
foundation.
muchos
Good
de vosotros estáis
afternoon,
conectados desde
because
España, pero
many of
somos
you are
becarios,
connected from
más de
Spain,
6.000 ya en estos
but we know
momentos, los
more
hay por
than
muchos sitios del planeta,
6,000
con
of
lo cual para
you
algunos
are
igual
all
es
over the
tarde,
planet.
otros
So for some
por la
of
mañana,
you,
así que buenos días
maybe it
también a
is
todos
the
vosotros.
morning, so good
Hoy vamos a
morning
hablar de
to all of you
inteligencia
as well.
artificial,
Today we
vamos a
will be
hablar de
talking about
inteligencia
AI,
artificial
and we will
y
be
hemos
talking
llamado a,
about
este encuentro un
AI, and
poquito
we've
más allá del
called
chat GPT, ¿no? Vamos a
this
intentar
event
profundizar más y
beyond
ver hasta dónde
ChatGPT. We'll
llegamos.
try to go
Tenemos
deeper and
cuatro
see how
charlas
far we
súper
can go. We have
interesantes.
4 very
Deciros que
interesting
hay
talks, and I would like to
traducción
say there
simultánea,
is
podéis escuchar
simultaneous
este
interpretation. You
encuentro
can
en
listen
español
to this
o
event
en
in
inglés y
Spanish
podéis
or
escoger
English. You can
lengua
choose
preferís seguir y que
yourselves
nos
which
gustaría
language
mucho
you
contar
prefer
con
to
tu
follow,
testimonio, que
and we
nos
would
lo podéis
like
hacer a través
to
del chat en
receive your
cualquier momento.
questions. You can ask
Dicho
via
esto,
the
y antes
chat
de
at
empezar con
any
estas
time. Having
magníficas
said
charlas que
this,
nos
and
esperan, me
before we
gustaría
start with these
presentaros
wonderful
a
talks that
Alfonso
await us,
Sánchez
I would
Moya,
like to
que es
introduce to you
miembro
Alfonso Sánchez
de la
Moya,
Junta
who
Directiva de
is
esta
a
asociación de
member of the
becarios
board of this association,
que
Becarios,
organiza este Becarios
that
Knowledge Day
organizes
con el
this
programa de Economía de
Becarios
la Caixa.
Knowledge Day with the La
Buenas
Caixa
tardes,
Foundation
Alfonso, te paso
program.
la
Good
palabra.
afternoon, Alfonso. You have the floor. Thank you, Silvia. Welcome, everyone. Good morning, good afternoon. Hello, my name is Alfonso Sánchez Moya, as Silvia said, and I am here representing the board of the association as a member, and I just wanted to welcome you. Thank you for being here with us, for joining us in these very motivating and stimulating set of talks that I am sure we will have in a few minutes. And as you will see, this is a central field, Sylvia just said, beyond ChatGPT. I think the talks we'll be able to receive today, together with the members of the association, are precisely this. They aim at engaging, seeing the impacts beyond ChatGPT, and seeing the actual and tangible impact. As leader of these projects in Apple right now, I'm looking forward to seeing these new innovations. And now I will pass the floor over to the rest of speakers. So thank you, welcome, and we hope you will enjoy this session.
Muchísimas gracias, Alfonso.
Thank you very
Pues
much,
nada, antes de dar
Alfonso.
paso a
Before I
primera
pass the floor over
ponente,
to the first
quería
speaker,
recordaros un poco
I
cómo
wanted to
funciona. Son
remind
unas
you
charlas de
how
10
this
minutos,
works.
de las
These are
cuales más o menos 8
10-minute
minutos
talks,
son
more or
las,
less
los que
8
están hablando nuestros
minutes
ponentes. Y tenemos
are
esos dos
the time that
minutos
our speakers
finales
take to speak,
para
and we
vuestras
have the
preguntas.
2
Así
final
que, por
minutes
favor,
for
id
questions.
afinando vuestros dedos y en cuanto tengáis una,
So
nos la pasáis.
get thinking of your
Yo seré la persona que
questions
intentaré
and
recordar
send them to
el
us.
tiempo es hora,
I'll
que tenemos
try
estos
to
8 minutos.
remind everyone that
He estado ya en
time
varias
is
ediciones y sé que
money.
la
You
gente
have
lo
8
toma
minutes. Everyone has
perfectamente.
always respected
Así que
them
si os
perfectly well. I'm
parece,
sure this will be the
empezamos.
case today as
Empezamos
well.
con la
So
primera,
we will
que
start. We
es
will start with
la
the
primera
first
charla de
one,
hoy, que la va a dar
the
María
first talk
Bausa,
of today,
y que
offered
nos
by
va a
Maria
hablar de
Bausa,
inteligencia artificial y
who will
robótica.
talk about AI
María
and
estudió en el
robotics.
MIT,
Maria studied at the
hizo allí
MIT, and there
su
she
doctorado en temas de
did her
robótica
PhD
y
in
ahora trabaja en
robotics.
Google DeepMind. O sea que
And now she
seguro que
works
puede
at
contarnos
Google
muchísimas cosas.
DeepMind, so I'm sure she
Y
will
que
be able
conoce
to
muy
tell
bien
us
también
many things. And
uno de
she
los grandes
also
modelos, ¿no?, de
knows
inteligencia
very well one
artificial
of the
que hay,
large
que es
AI
el
models, Gemini,
GPT. Pues nada,
which
sin
is the
más dilación, os paso ya
modeled
con
by
María.
Google.
María,
So without
buenas
further ado,
tardes.
I'll pass the floor
Buenas
over
tardes a
to
todos.
Maria. Good
Muchas gracias,
afternoon.
Silvia.
Good afternoon,
Empiezo
everyone.
con mi
Thank you, Sylvia.
presentación,
I
que
will
va a
start
ser
with my
sobre cómo
presentation,
llevamos la
which
inteligencia
will
artificial
be
a la
on
robótica.
how to take AI to
Entonces,
robotics.
para ello, creo que
And for
tiene que
that,
hacer una diferencia
I
entre
think we
cómo
need to make a
conseguimos inteligencia
distinction
artificial y cómo
between
conseguimos una robótica
how
que
do we
sea
get
capaz de
AI
llegar
and
a
how
nuestros
do we get
entornos.
robotics that
Para ello, quería
can
dar un
have an
ejemplo
impact
que
on
es,
our
si le
environment. And
pedimos a
for
la inteligencia
that, I
artificial
wanted to
que
give
nos
you an
cree
example.
una
If we
imagen
ask
de un
the
robot cogiendo la
AI,
taza,
give
nos
me
dará 10
10
imágenes.
images of a
Y
robot
más o
grabbing
menos nos
a
parecerán
mug,
decentes.
they will
Diremos,
give
bueno,
us these
sí,
10 pictures and they will look,
resultonas,
yeah,
nos
decent,
sirven.
nice, all
¿Qué
right, will
pasará si le
do.
pregunto a un robot,
What
dame
happens
una
if I
taza, por
ask
favor?
a robot, give
Nos
me a
esperaríamos lo
cup
mismo, ¿no? Que el
or a
robot coja
mug?
la taza, una
Please, we would
pregunta haré muy
expect the
simple,
same
no nos
thing, a
costará nada
simple
nosotros como
task,
humanos
something
y
that doesn't
pasaría como
cost us
esto, ¿no?
anything as humans. It
Pero ¿qué
may look
pasa
like this,
si
but
el
what
robot nos
happens
rompe la taza?
if the
Y
robot
aún peor,
breaks the
¿qué pasa
mug?
si tenemos un
What
robot que falla
happens
una de cada 10
if we have a
veces?
robot that
¿Tenemos
fails
un
1 in
problema?
10 times? Do we have an
Pues
issue
sí,
here?
porque si tú tienes10
Yes, we
tazas en tu
do.
casa, al
Because
cabo de
if
unos
you
100
have
días, que
10 cups
son
at
menos de
home,
3 meses y medio, te
after
toca
100
comprar
days,
nuevas
which is
tazas.
3.3 months, you
Y
will
si
have to buy
rompe una taza cada
a
10
new set
veces,
of
te
mugs.
puedes imaginar los
And you
platos,
can imagine if
vasos,
that
toda tu
happens,
vajilla
well,
ya la puedes
same thing
renovar.
will happen with
¿Qué pasa ahora si en lugar de
dishes,
esto te la rompes
glasses.
una de
You
cada 100
can
veces? Bueno,
buy
pues si
the
solo
whole
usas una taza cada
set.
día,
You will have to
pues
buy it
cada 1000
frequently. me.
días, al cabo de 3 años,
What
toca cambiar
happens
tazas,
if
pero los
they break
vasos, a lo
it
mejor
every
los utilizas una vez cada
1,000
día, otra vez a cabo
days?
de
Well,
3
maybe you
meses,
will have to
ya
buy a
tienes
new
que
one
estar
every
comprando vasos.
once and
No
again.
nos
But if
sirven
you use, for
robots
example,
que
10
más o
glasses a
menos,
day,
como
you
las
will
imágenes
run
que
out of
veíamos, que
glasses
más o menos
in
están bien,
100 days.
no nos
So
sirven.
we will not do with
Entonces,
robots that
parece
are
razonable
more or less
pensar que a lo
okay, that
mejor
are
la
so-so. So
robótica
it seems
es más
reasonable to
difícil que la
think that
inteligencia
maybe
artificial.
robotics is more
No
difficult
digamos
than
tanto,
AI.
seamos un poco más humildes,
Let's be a bit
pero yo
more
lo que creo que
humble.
sí que es cierto
I think
es
what
que la
is true
robótica no
indeed
puede
is that
pasar sin que no
robotics
hacemos los avances que
cannot
tratamos en la
happen
inteligencia
if we
artificial.
do
Van de
not
la mano y
carry
son
out
muy
all of the
importantes.
necessary
No
advances in
haremos
AI.
avances
This
en
goes hand in
robótica si no
hand.
los vemos
We
antes
will
en la
not see
inteligencia.
headway in robotics if we do not
Entonces,
see it
dicho
first in
eso,
AI.
¿cómo
So having
hacemos
said that,
progreso en la robótica?
how do
Yo
we
creo que hay dos
progress?
ejes.
How
El
do we
primero es
make
la
progress in
precisión, el
robotics? There
ser
are two
capaz de
axes.
hacer
The
las
first one
cosas
is
bien, como justo lo que
precision,
decíamos ahora con
being
las
able to do things
tazas, ¿no?
right, just like
Pero
with the
también hay
example
la
of the
parte de ser
mugs.
adaptable, de ser
But same
general,
thing
porque tu
about
robot tiene que
being
trabajar en tu
adaptable
casa,
and general,
pero
because
tendría
your
que
robot
trabajar
should
otra
be
en la
able to
mía,
work in
en
your
una
home, but also
fábrica,
in
por la
mine, in a
calle. ¿Cómo
factory,
conseguimos
on
que
the
hagan
street. So
muchas
how
cosas en
do
muchos
we get them
entornos,
to
¿no?
do
La idea
many
de tener
things
un
in
robot
many
que
different
realmente sea
environments? The idea
útil.
of having a robot that
Entonces yo creo
is
que hay que ser como
useful,
en
truly
dos
useful.
ejes.
So I
Y
think
para
we
ello,
have to
hoy os voy a
focus
dar
on
un
the two
poco la idea de
axes.
cómo
And
estamos
for that, I
haciendo
wanted to talk a bit about the
investigación
idea
en el
of
campo de la
how we are
robótica.
doing research in the
Todo
field of
empezó para
robotics.
mí al menos
To
en el
me, at least,
2017,
everything started in
cuando usamos
2017
AI muy básica para
when
hacer
we started
progreso.
using very
En ese
basic
momento Amazon
AI
nos
for
dijo,
progress. At that
os vamos a
point,
dar
Amazon said,
este cubo,
we're going to give
esta
you
caja
this
llena de
bucket
objetos, lo
full of
sacáis todo.
objects,
Haced un robot
pull
que sea
them
capaz de
on
hacer eso.
all out,
Suena muy
build
simple.
a robot
En
that
ese
can do
momento,
that. It sounds very
2017, no
simple.
había una
At that
solución
time in
que fuera
2017, there was
general y
no
buena
solution that
para
was
solventar esto.
generalized and good
Nos
to
pusimos
solve
a
this
ello, un gran
issue. We
equipo,
got down to
MIT,
it, a big
Princeton,
team,
bueno, lo
MIT,
conseguimos, pero
Princeton.
ponía muy
We
básica.
managed, but with very
Sabemos que la
basic
AI ha
AI.
mejorado.
We know
Entonces ahora
that
ya
AI
podemos
has
hacer más
improved, so
progreso
now
en el caso
we
de la
can make more
precisión, con
progress
una
in
IA que
terms of
llamaría modular.
precision with a
Modular, ¿por
modular
qué? Os enseño
AI.
un
Why is it
ejemplo que hicimos
modular?
en
I will
MIT.
show you
Aquí tenemos
an
este
example
robot que no
we
solo coge
did in
objetos,
MIT. We have
sino que
this
los puede
robot that
poner de
does not
forma
only
muy
pick up
precisa
objects,
en
but
un
can
sitio
place them in a
determinado.
very
Eso es
precise
importante
manner in
porque
a
luego
very
esos
particular
objetos se pueden usar para
place.
otras
And
cosas
this is
porque quién sabe
important
dónde
because
están.
these
La
can then be
inteligencia
used
artificial que
for
usamos aquí
other
es para
things.
tacto, para
The AI
visión,
we use
pero sigue
here is
siendo
for touch
básica
vision,
en el
but
sentido
it's
de que
still
hemos tenido que controlar
basic,
mucho
meaning that we have had
el
to
entorno.
very much control
Pero
the
podemos hacer más que
environment.
eso.
But we
Y
can do
aquí es
more
donde
than
entra el
this.
momento ChatGPT, el momento de
And
los
this
grandes
is
modelos,
when
los
ChatGPT
large
and
language
the
models.
big
Y en mi
or the
caso, como yo
large
trabajo en
language
Google,
models
hablaremos de Gemini.
come in. And since I work in
Entonces, lo que
Google,
queremos
we
con
will talk
Gemini,
about
nosotros lo
Gemini.
llamamos Gemini
What
Robotics
we do
y
with
hemos
Gemini, we
sacado
call
ya
it
tres
Gemini
versiones
Robotics.
este año.
We have
La idea
already
es que
published 3
queremos
versions this year.
que sea
And
dexterous, que quiere decir que
we
tenga
want it to
destreza, que haga las
be
cosas muy bien,
dexterous.
interactivo, tú
We
le
want it
puedes
to be
hablar en
interactive. You can
español,
talk
en
to it
inglés, en
in Spanish,
alemán
English,
y que sea
German,
capaz de hacer lo que tú
and it should
decides
be
y
capable
general,
of
otra vez, que
following
sirva para
directions.
muchos diferentes
And
entornos.
general, it should
Y lo
be
hacemos basado en Gemini,
useful
que es el
for different
ChatGPT de
environments.
Google,
And we do it
que
based on Gemini,
entonces es
Google's
multimodal.
ChatGPT,
Puede
which is
tener
multimodal.
imágenes, audio,
It can
texto.
support
¿Cómo
images,
combinamos
audio,
eso para la
text. So
robótica?
how do we combine all
Aquí
of
tengo un
these for
ejemplo
robotics?
que os voy a mostrar
Here I
un
have
poco
an example
rápido,
that I
como
will
dónde
show
podéis ver que es
quickly
interactivo. Le
to
acaba de pedir al
sort
robot que
things.
ponga
It just asks
la banana, el
to
plátano,
place
en
the
el
banana
contenedor.
in the container.
Como veis, eso lo hace de forma
As you can
autónoma,
see,
sin que haga
it does it
falta que
in
hacemos
an
nada más.
independent
Y es un
manner
modelo
without us
entrenado
needing
con
to
un
do
montón de
anything.
datos. Ahora lo voy a pasar rápido.
Now,
Le he pedido que le
I
ponga las
will
uvas
fast forward.
en
It
el bol
asked it to place the grapes
naranja.
in the orange
Entonces, como
bowl.
veis, él puede ir jugando
So
y
as you
molestando
can
al
see, he
robot,
can
pero el
play
robot ha
around,
entendido
disturb the robot,
lo
but
que
the
tiene que
robot
hacer. Entonces puede ir
understood what it
poniendo.
had to do.
Ahora le pido que lo ponga en el rosa.
And
Y
now
lo va a
in the
poner en el
pink
rosa. O sea, que
container.
si se equivoca, se da cuenta
It
y
makes a
entonces
mistake,
lo pone en el
realizes,
correcto.
and then puts it in
Y
the
le podemos decir ir
right
haciendo que haga
container.
muchas tareas.
You can ask it to carry out many
Entonces, no
tasks.
solo esto, sino que también
So
hemos
not only
visto que
that,
cuando
we
tú
have
quieres hacer una
also
cosa muy
seen
difícil,
that when you want to
si
do something
consigues
very
suficientemente
difficult,
datos, en este
if you
caso son
get enough data,
del
in
orden de
this case
miles
it
de
is around
ejemplos de cómo hacer esa
thousands
tarea,
of
te
examples
pone
of how
cosas
to to carry out this
difícil como jugar a
task.
origami.
It can
En
do
este
very
caso, en
difficult
este
things,
vídeo,
such as
voy a pasar
origami.
rápido, pero
In
sí
this
que tenemos
video, I
aquí de
will
un papel de
fast
un
forward
cuadrado
it.
a
We
la
will go
cara
from a
de lo que
square
sería
to
un
the
fox, que es un
face of
zorro
a
en español.
fox.
Entonces, es una tarea muy
And
compleja,
it
hay
is a
que
very
hacer mucho
complex
contacto, hay que hacer
task.
muchos pliegues,
It
pero al
requires
final
a lot
el
of
robot es capaz por
contact
sí
and
mismo, de forma
folding, but
autónoma,
the
de
robot
haceros la cara del zorro que
on its
tenemos.
own can make this
Aquí la tenéis. Y
fox
luego
face,
también hemos podido ver
which is
que
what we
con la
asked.
misma solución, pues
And
hacer
with the
tasks que
same
otra vez requieren mucha
solution,
precisión.
you
En
can do
este caso
things
es
that
una
require
tasca de industria
precision. This is an
que se llama
industrial
bajar
task.
mist.
nest timing belt assembly. The person tries. It needs a lot of strength. It requires a lot of strength, but the robot can do it on its own by combining lots of data together with the large language models, which also include vision and actions. This works very well, and it does because we have teleoperation. We have people next to the robot making it do what we want it to do to connect the data. But at the same time, this is an issue because it's costly and limiting. Costly because for each task, you need persons and robots that can remotely operate the task. But there's also the issue that if you can only do it at a certain level, very slowly, watching out, the robot cannot do it better. You're limited by the quality of your own remote operation. And this is when we get to what I think are the next stages for robotics, which is learning by reinforcement learning. So I will leave you with an idea of how we've done this reinforcement learning in our robots, represented in the quad robotics. But the idea is that now we can control even more complex robots with fingers. Here they have 3 fingers, and you can see an example in which it picks up the object, manipulates it, and it makes an insertion. And here it can even pick up the bulb and slowly see how to place it inside and have it light up. So, how is this important? Why is this important? Because the idea is that we want to make progress in robotics. And I think I've given you good examples of how AI is truly having an impact on us getting further with robotics. But at the same time, there is a lot of work ahead. And this is something that we have to understand. We will not see robots in 3 years, but we are making a lot of progress. Thank you. Congratulations, Maria. 8 minutes, 0 seconds. 8 minutes on the dot. Thank you very much, Maria. I have a couple of questions for you. We have time for that. I will go back to one of the questions that our audience submitted, and they asked about your definition of audience and to what extent do you believe this AI will become similar or better than human intelligence? And along those same lines and adding robotics, because if we imagine AI which is plotting against us, that's one thing. But if you imagine the robot coming to you, that's something that maybe we should fear. I don't know. What do you think will happen in the future? I'm optimistic myself because I think changes in robotics do not happen overnight. We will not wake up one day surprised thinking, how did we come this far? Because robotics in the end need to act in the physical world. And this means there is a component of the robot in and of itself. We need to build it, learn how it works. And this gives us a lot of control and a great capacity to investigate in terms of safety. On the internet, things can get out of hand, but I think in the robotic side of things, there's a lot of road ahead, and it gives us the advantage that we have time to think about security, how we manage security. In a sense, well, robots will be able to carry out tasks that humans do not want to carry out, cumbersome tasks that we do not want to carry out. And a good thing is that we can design the shape of the robot based on the environment. I mean, you cannot design your own hand, but you can design the hand of a robot to make things easier. So it gives us some room to play around, and it will give us this component, which is a tad different from what we've always imagined or what we've always been able to do as humans. So the idea is to see how AI advances and how we add this component of understanding the physical world. This is what's difficult now, because sometimes when you generate images, there are things that are nonsensical. But in robots, if you start seeing nonsensical things, it will not work. So we need to make their understanding of the world based on real things so that they can act and modify it in a useful and effective manner. Thank you. And very briefly, because we move on to the next talk, could you tell us what is the next big thing we will see in robotics that will be jaw-dropping? What will happen next year or the year after? I think robotics, or in particular what I do, which is manipulation handling, has an issue because you show these videos to my mom and she'll say, yes, but I can do that. But then we have other robots which are humanoid that make lips and turns and twists that I will never do in my life. So we have a problem because these jumps and leaps, in a sense, are easier than picking up a mug and doing something with it. So what I think we will do is that we will increasingly see that industrial problems that were very rigid in the past, where we needed a lot of structure, where we will be able to use more flexible solutions. Having a robot that does something that is jaw-dropping is difficult, but because in terms of handling, we are the world experts. We're very good at it. But I think we will see a lot more adoption of robotics. We will see videos that will be incredibly impressive, increasingly impressive, because the robots will be independent. We'll see more and more of that. Thank you very much, Maria. And now on to the next speaker. We will now talk to Juanjo Belza. He is a doctor in internal medicine. He worked at the University of Navarra and in tropical medicine in the Milagro Hospital in Uganda. And now he's working at the European University in Madrid. And there he's director of a research and AI group. So we will start talking to him about AI and health, which we'll see is a topic that we will hear about from other speakers as well. Juanjo, you have the floor. 8 minutes. See you after for the questions. Thank you, Silvia. Well, first of all, just to give you some context, we will show the framework of what is ChatGPT, which is the title of today's session. It's a large language model with a transformer structure, which is part of generative AI, which in turn belongs to deep learning, which is a type of neural networks, which in turn are a type of machine learning algorithms, and it is one of the central tools of AI. There are different ways of being able to use these models. Maybe the most well-known one is in the cloud through a website such as chatgpt.com, which is where most users are using. There are other websites, Perplexity or Grok or Claude, which give us services with other models. Many people know them as well. And then there are accesses, such as accessing the cloud through APIs, such as the site of Hugging Face, OpenAI, Google AI Studio, or OpenRouter. And then there is a different way of exploiting the models, which is locally, be it via a terminal with Oyama, just by writing these lines. Oyama run Queen 34B. You can execute a model through the Oyama app or the LM Studio. Here we see a terminal executing Quen. We can ask things just like with ChatGPT, but locally. And this for healthcare is very relevant because there are patient data that we cannot share because we do not have its ownership or due to privacy concerns, but we can exploit them locally. We can run them locally. This is the Oyama app, and this is LM Studio, where we can modify the functionality of the model by changing its creativity through temperature or the tokens you will select, etc. How many models can we use? We have this open source repository in Hugging Face. A week ago, there were 2.128 million models. What does this mean? There is life beyond ChatGPT. In these 2 million models, there are models for healthcare, for architecture, for art, cooking, physical education, thousands of different things. And these are models that have been fine-tuned or adapted to each of the tasks. I will not name them all, but Gemini was mentioned, DeepSeek, Copilot, Claude, Quen. There are many models. And very briefly, what a ChatGPT and LLM does is we ask it to carry out a task, for example, translating Javier tiene malaria into French. It tokenizes it, turns it into numbers. They enter a multiple vectorial space through embedding. Then it goes to the encoder of the LLM. Then it goes to the decoder to generate these output tokens, which become words. I'm simplifying it excessively, but it is in the end a predictor of words. Every word is placed in a vector, of up to thousands of dimensions. Here we showed graphically 3 dimensions, and the model calculates the angles, the deltas between words, so that the closest words, doctor and patient, will have an alpha angle that is very small, because in the training text normally they are near one another. So the only thing that an LLM does is to place all of the training words, which are millions, into a space in a map, and finds these angles where it can operate transformations. And beyond doing that, in order to generate text words, what you can do is you can add the RAG, giving it a text that it can rely on, so that the answer will be more set and more reliable, so that that text that we add, it adds it to our question, to our prompt, and then it uses a model to be able to give a more reliable answer based on the texts. A safer way to do this is not just adding a text that will go into the prompt, but doing a fine-tuning, which is modifying the weights, the internal structure of the model, in such a way that we do a transfer learning. We retrain the model based on a series of tasks or texts that it had not been trained with before. This is an MIT study as well, where they prove on the left, on the red arrow, we see reliability degree. And the least reliable is to use a general model such as a ChatGPT for a clinical answer. This is the worst by far. And then we can do a fine-tuning of a general model. This works a bit better. And if we do a fine-tuning with clinical notes and clinical tasks, it works a lot better. This is the line that our work ESLUT works on. And then if we develop a model from scratch with clinical notes, it will work very well, but the cost will be huge, and the amount of data as well. And the final step would be not just having a model that works well for our language and our text, but being able to add an activity, an agent, a tool that can lead to an action, not just giving us a conceptual answer in text, but also acting, be it as a single agent at the top center or a multi-agent with multiple potential action arms. I'll finish by talking about a publications by Nature from a few weeks ago. They developed Delphi 2M, an algorithm developed with an older, smaller algorithm, GPT-2. Now we are on version 5, which can be deployed locally, not necessarily in the cloud. It can work with more than 1,000 diseases, and it finds connections between them all. It performs a time sequence predicting what disease will come after and in what period of time. It has been trained public data, the UK New Bank, and it has been tested in a Danish population with a precision of 0.75, which dropped to 0.67. This is still undergoing research, but it opens the door to using these large language models to predict individual and populational diseases. My conclusion is that there is life beyond ChatGPT, no doubt about that, but LLMs will become smaller and promoted or powered by RAG and fine-tuning. AI agents will be a new league. They will be multi-potential with multi-agent architectures, and that all of this leads to big privacy and security problems that we will have to respond to. And to me, this is the fourth industrial revolution, no doubt about that. Thank you very much. Thank you very much, Juanjo. We have an extra minute thanks to you. We have time for questions. And I think what you're talking about sparks a lot of interest, a lot of questions. So I have a few questions. One is from the audience, or a few are from the audience, because one of the questions we got was to what extent we can rely on this AI. And this is even more important when we talk about health. And connected to this, I was also thinking about where is the responsibility of the error, because humans make mistakes. And there's regulation, there's a set of rules to define where the responsibility of the error lies. What happens when the one making the mistake is an AI? You talked about, well, we will know what the next disease will be, but what if we make a mistake? I would say you can never rely on an AI as of today until proven otherwise. Sometimes it can be proven, but not always. And we always need to make validations with local data. A validation made with a product developed in another country with different databases, a different population, different epidemiology. You always have to doubt that that result will work well in our population with our data and our means. However, the potential and how the models are perfected, well, we are at top speed with that. And I think we will slowly come closer to the time when we will be able to draw value out of the LLMs. But as of today, we need to always perform a human control check. Except in very specific fields, the decision always should be in the hands of the clinician, the doctor, the nurse. And in the flowchart of decision making, AI is a support tool. It is not a decision-making tool or an autonomous tool. There are areas, for example, in insulin, diabetes, they are practicing with autonomous models. But generally speaking, we still need to check whether it works or not. The second question is more about responsibility. And again, the model we're working on as of today says that all of the responsibility is in the hands of the clinician, and the AI can give advice with specificity, sensitivity, area under the curve parameters, but taking into account that it does not work 100% with total precision, as of today we do not have that, the decision and the responsibility is always in the hand of the clinician for now. One final question before we move on to the next speaker. You talked about data and the importance and the security concerns. So based on where we are now, can we be reassured? Because we need to continue feeding these AIs with real data for them to be good for something. So can we be reassured in terms of how these data are managed? I don't think we can be automatically reassured. I don't think there's peace of mind. We need to make sure what data we want to share in terms of our personal data or the data of our care population or our patients. I think you can do things very well and things that are very wrong. I would not say that generally speaking we can rely on this, but I wouldn't say the contrary either. Each platform, each company, each research project, each hospital, depending on whether the data are in the cloud or locally, depending on the structure, who you share it with. All of that is the fine print that I think we need to read, especially with health data, which are very sensitive. Thank you very much, Juanjo. We'll continue to talk about this because actually our next speaker will also talk about from data to action in AI, in public health and medicine. So I think we will continue also talking in future Becari's Knowledge Day events. This just started. Thank you, Juanjo. Welcome, Irene Martinez. She is a doctor and epidemiologist specializing in environmental health, and she works at Vital Strategies, which is a non-profit working with governments and organizations, national and supranational, in the area of public health. She's also an associated researcher at Columbia University, and we are looking forward to listening to you, Irene. So go ahead, talk to us about this data and these actions in health and AI. You have the floor. Thank you so much. It is a pleasure to be here today and to continue along the lines of the previous talk and to talk a bit more about AI in public health and medicine. I think it's a very important topic because AI is transforming the way in which we study, prevent, and treat diseases. In order to understand the impact of this revolution on science, I think it's useful to understand how AI has revolutionized the scientific method. Traditionally, the scientific method has been a clear sequence. It starts with the human observation of a phenomenon, continuing with the formulation of a series of hypotheses. Then we design an experiment. We analyze a series of data to confirm or discard the hypothesis. It is an essentially linear process that traditionally has been guided by human experience and intuition. With the integration of AI, this changes because observations no longer depend only on the human perspective, but they can derive from the integration of thousands and millions of data. some that cannot even be captured by the human eye. This allows us to generate hypotheses that are more complex in a shorter time span and obtaining results that come closer to the complexity of the phenomena in real life. And these, in the field of medicine and health, can come with revolutionary advantages. For example, in applying these to my research in environmental epidemiology, we know that more than 70% of conditions are due to non-genetic causes, and until now, preventative medicine has focused mainly on a modification of individual habits such as exercising, a good diet, or non-smoking. But we know that reality is a lot more complex and that we are simultaneously exposed to a myriad environmental and social factors. But these factors are very complex, they are multidimensional, and they interact with one another and they are cumulative over time. This is why social and environmental determinants of health have traditionally been quite difficult to study and capture with the classic research methods. Now, AI has the potential to change this paradigm and go from a more individualized vision of disease to a more systemic perspective. We will see with an example, a specific example of my own research, with the case of the exposure to metals and cardiovascular disease. Metals such as arsenic, mercury, can be issued by many sources, but in real life we are not exposed to one single contaminant in a single moment in time. We're exposed to complex mixtures. So can we study the impact of these metals on health and their interaction with other factors? The answer as of today is yes, we can, because thanks to the use of laboratory techniques and the application of AI methods, we were able to quantify the impact on mortality of exposures to complex mixes of contaminants in a cohort of adults in the United States. The models allowed us to take into account the interactions between or amongst metals, but also the interaction with other factors of the environment. In our study, we observed that people with highest levels of these mixes of pollutants had up to 30 and 66% higher mortality risk due to cardiovascular causes and total mortality. This opens the door to the development of new strategies and tools that integrate these factors that we know are modifiable as new ways for prevention and clinical practice. And the case of metals is an example, but it's not an isolated case. There are several emerging pieces of research in environmental health to broaden this paradigm and integrate environment factors such as air pollution, green spaces, social environments in prevention of diseases, although there is a long road ahead. And it's not coincidence that I brought one example that Juanjo already showed, so I will not get into the details, but one of the most impressive developments in disease prevention and risk is this Delphi 2M model. This was published less than a month ago in Nature, and it was trained with data from millions of patients in several countries. Juanjo already talked about this, but I will just add that this model can be very useful for healthcare planning and also to increase accessibility to patients in terms of calculating risks. It's very important to maintain the doctors in the decision-making circuit, as we already had. In some cases, the use of AI is the only viable alternative for diagnosis. For example, in the case of diabetic retinopathy, which is the main cause of preventable blindness in the world, with 485 million diabetics in the world and only 200,000 specialists. If we do the math, it is impossible. It's an impossible equation. So in this case, the screening tools based on AI allow us to resolve this equation, making screening accessible to more people and just sending the necessary cases to the specialists. Another impressive thing about AI is the capacity to return the voice to patients who lost it. Small devices are being developed that capture movements of face muscles and turn them into electric signals that can become voice patterns. This is part of a field called brain-computer interface that connect patterns with specific sounds or syllables. The AI AI can help us understand causes of disease, prevention and diagnosis, and even gain back functions that one had lost. And it's also very useful in decision making. But we need to take into account that there are a series of risks. First, the quality and representativity of the data, which is crucial. If algorithms are trained with data that do not reflect the diversity of the population, results will be biased or even discriminatory. And then there are risks in terms of biosecurity, for example, connection to the internet. So it's an ethical, political, and global challenge, and we need regulation to approach that. And models make mistakes. We all probably know about the hallucinations of AI, and some studies have recently detected that the AI can deliberately lie, manipulate, or act in an unforeseeable manner. We need to be very much aware of this and establish verification and control strategies. We cannot forget about the environmental impact of AI. The role of renewables should be key to maintain this development in a sustainable manner into the future. And to finish, I wanted to talk to you about something a bit less known about AI and applications of AI in health. Small, low-cost, low-energy consumption technologies that can reach every corner of the planet. In this case, I want to talk about the TinyML initiative that consists of small devices that work off the internet and that are being used in environmental and public health projects in several places in the planet. For example, in Brazil, they're using them to detect anomalies in heartbeats, in Peru to diagnose anemia without the need for lab tests, and in several tropical countries to distinguish types of mosquitoes based on their buzzing, preventing dengue or malaria control. Another important aspect is the power of AI to combine with citizen science. AI allows communities to participate directly in the collection and analysis of data. And something very important, the combination of AI and citizen science can become a true force for social transformation. This is supported by several examples, such as the case of the government in Togo, which during COVID-19 implemented an AI system connected to mobile and satellite networks that allowed to identify vulnerable homes based on the information provided by the citizens and manage the payment of aid in remote communities. Another case is the Missing Maps initiative, promoted by humanitarian aid NGOs. This initiative allows different volunteers in the world to identify vulnerable areas that do not have detailed maps using satellite pictures and open source tools where everyone can participate. These maps, for example, are crucial in natural disaster, epidemics, and humanitarian crisis response. And just to finish, my conclusion is that we know that AI is transforming the way in which we study, prevent, and treat conditions, and it can also be a tool for collective justice and well-being. However, in my opinion, the challenge of the coming years will not be only to develop more powerful but more human model systems that integrate diversity and equity and that respect privacy and work at the service of health and sustainability. And with this, I wanted to thank you because I know I took a bit too long. I went over. So thank you, Fundación La Caixa, for the invitation and for the PhD grant that allowed me to study in Columbia University. And I wanted to take the opportunity to share a project that we launched recently in Spain, Arthur Domingo and myself. Arthur was a grant holder of La Caixa as well. This is a scientific dissemination project, and you can sign up to it with the QR code on the screen. Thank you very much, Irene. Yes, we went a bit over time, so we will leave it at just one question, and I will ask you to answer briefly. Well, you talked about so many things. You talked about the smallest things to the largest ones, the benefits and the dangers. So just to concentrate this all in one question, you talked, for example, because I thought, well, one thing is the diagnosis and the big advantages of diagnosing rare conditions, and spotting these rare conditions. But I wondered about this danger that people talk about. We will stop thinking, and this you can see with simple statistical data. Sometimes you do not see the outlier in this statistic, and not in terms of the rare disease, but in a common disease, one that for whatever reason behaves differently. I don't know to what extent you think this is a risk and where are we headed, and maybe if you can answer very briefly, because there's so much to do, but will we have enough power for everything that you're talking to us about? Thank you. Yes, I think the fact that we are going to stop thinking, statistical analysis tells us so. We use chatbots for very simple tasks now. And this applied to medicine should show us that both clinicians, human action is necessary. We need to humanize these tools and use them at our service. We should not trust them blindly for personal use and for medical use. That's why, for example, in the application of all of these tools of disease prevention, we need to involve clinicians in every decision-making process. This is key. I don't know if we will be able to do everything, but I know it is a very promising field and it is expanding to different multiple areas. It can be a revolution in terms of prevention because it is opening doors to tackling factors that until now we couldn't even imagine, including in risk estimations and prevention models, populational and clinical models. So I think in that development, we should not miss our focus. AI should reach all countries. We cannot forget about vulnerable countries, countries with less resources, because these tools benefit them as well. And on many occasions, this is where they are needed the most. So that would be my last message. Thank you very much, Irene. We'll stop here with you and we will move to our fourth and last speaker of tonight. I committed to say the name right, Albert Giroge, and he works at the AI Center of AstraZeneca. And before that, he did his PhD in the supercomputing center in Barcelona, and he's also been at the Technological Institute in Tokyo, the lab of the Tennessee University. So we will talk to him once more about this AI and see if it's scalable, if we can go from these machines to humanity, talking about health, but not only health. So Albert, I'll pass the floor over to you. 8 minutes.
Thank you. Thank you very much. It's really nice to be here. And it was amazing listening to Irene, and I think it's a very good transition from Irene's talk to my talk, because I feel like we were almost talking about the same thing. And at one point I thought, like, I don't need to make my presentation. Irene has already said everything that needed to be said. But it's really good to be here. My name is Albert. I'm an AI engineer at AstraZeneca. And my talk today is going to focus more on building AI that scales. For the last 10 years of my life, I've really been obsessed with this word scaling and understanding how to scale things and all these things around scaling. So I want to build on that and mention a few things that I've been doing in the last couple of years that I think are important for the next frontier of AI. So I did my PhD in Barcelona Supercomputing Center, as it was already mentioned. And during my PhD, I was very interested in the idea of scaling machine learning and deep learning across many, many nodes in the supercomputers that we had. So this was about high performance computing, thousands and thousands of computing nodes. It was also like designing and coming up with algorithms that could run on supercomputing clusters, and also looking at distributed systems and how those distributed systems work, like failure in distributed systems, and also the infrastructure to process massive amounts of data. So these things ranged from the software to actually thinking about the hardware itself and how that were being connected. And my PhD thesis was actually titled "Convergence of Deep Learning and High Performance Computing." And in this, I tried to look at the challenges and the opportunities and some of the solutions that came out of that. So I spent a lot of time doing that, about 3-4 years of my life, and I was looking at the simple compute node that we had in the supercomputing clusters, and it has, let's say, 4 GPUs or 8 GPUs depending on where it is. And then when you put those together, when you put thousands and thousands of those nodes together, then you have what we call a supercomputer, what we used to have at Barcelona Supercomputing Center, Mare Nostrum. Now I think there is a new version of Mare Nostrum. And then I was interested in looking at how I could process data across these computing nodes, right? From one node that we have here to thousands of nodes. Of course, that comes with a lot of challenges. You start facing things like networking challenges. You start facing things like data distribution challenges and all those kind of things. So it involved coming up with very smart algorithms to train these models in really large networks. And I'm very proud to say that part of that work that we did is what has enabled us to get to where we are today in machine learning and AI. Like tools like ChatGPT are built with these algorithms that were built back then, and a lot of the infrastructure that, when you send a message or when you chat with your ChatGPT today, a lot of that is running behind these massive infrastructures. I think you have lately been hearing a lot about new data centers coming up everywhere, the competition for energy between cities and data centers and all that kind of thing. This is because of these massive supercomputing facilities that are consuming this amount of data. And so that was an aspect of scaling that I was very, very interested in. I published quite a number of papers around this topic, looking at how to design algorithms, how to solve for failure rates, and how to scale efficiently. And then in the last year of my PhD, COVID happened. And when COVID happened, it was a pandemic, we were all locked indoors. A bunch of us realized that a lot of the information that was available online and anywhere was in the dominant languages. It could be in English or French or Spanish and whatnot. But then to thousands of people, or actually millions of people who don't speak these languages, they couldn't access any information that was available about COVID and that was rapidly being generated about COVID during that time, right? You remember during that time, things were changing rapidly. We didn't have a lot of scientific knowledge on what was happening, so things would change rapidly. And imagine that half the population of the world cannot access this information because they don't speak that language. So a bunch of us, mostly from African continent, came up, sat down and decided to create the first cross-lingual open retrieval question answering for African languages. And the idea was simple. If I can ask any model that time, or even on WhatsApp, a question in my language, let's say Kiswahili, and the answer of that question exists somewhere in another language, say in English, can we have that cross-lingual and can I get an answer back that is important? So this was quite important because, for example, my own mother doesn't speak English. And such people needed to have access to this information. So we sat down and created this first data set called AfriQA, and this was to be a building block of what we wanted to see in the future. And so I'm slowly trying to shift to what now scaling started meaning for me. So after that, I realized there was a lot to scaling than just scaling machine learning in data centers. Scaling needed to have a new meaning, and that's the meaning I've been pursuing for the last couple of years, let's say 2-3 years. Scaling means scaling across people. It means scaling across languages. It means scaling across diseases, across context. So nowadays, in as much as I'm still very interested in scaling machine learning in supercomputers, I'm interested in going beyond the data center, going into the real world where the AI makes the difference, right? How do I go from scaling to thousands of nodes to scaling to millions of people who don't speak particular languages, who have a very specific context, like Irene was talking before, and all this kind of thing. So that, for me, is the new meaning of scaling. And it turns out I'm not done being obsessed with this idea of scaling. I'm still very, very interested in scaling, but I've just moved from scaling in data centers and in machines, not completely left it, but also now thinking about scaling to humanity, right? So scaling across people is one of the things I'm very, very interested in. AI must scale to those people who are often forgotten. What does that mean? We need to build AI that actually understands and serves communities in their native languages, not just English. And that has been the problem of a lot of the digital technology for a very long time. And in healthcare, we need to think about, diagnostic tools and medical insights to rural clinics, underserved populations. And I know a lot of the research right now in AI for drug discovery and all that is focused on, blockbuster drugs and the next big thing in cancer treatment and all that. But more often than not, we forget about the other diseases that also kill millions of people across the world that are often ignored. So that is another aspect of scaling that we need to be thinking about. And in education, we need to be creating learning tools that reach remote classrooms and resource-limited settings. So that's scaling across people. But we also need to scale across communities, right? I am part of the Deep Learning Indaba, which is an organization that has been conducting AI training and conferences across Africa. It's specifically based in Africa. And this idea came up from the founders who were attending NeuroIPS, one of the largest machine learning conferences, and realized there was not a single paper from the continent. And then we actually have this thing that we call among us the missing continent. There was not a single paper from the continent. And they came back and said, we needed to solve this problem, right? So they formed Deep Learning Indaba. And because of this organization, we have had now every year, we have hundreds and hundreds of papers at the top conferences. Think ICML, NeuroIPS, and all that coming from the continent because of this organization. Every year we organize the conference to train, masters, undergraduate people on AI, and we partner with them, we mentor them to publish in top conferences and to do research that actually solves the problems that exist. So this is scaling across communities. Next year, I'm going to be the general chair of Deep Learning Endeavor, one of the greatest honors of my life. And to see this happen, and continue to grow is also the other aspect of scaling that I'm talking about, scaling through communities. But also in science and scaling science scaling in science and scaling AI in science responsibly. As I mentioned earlier, I work at AstraZeneca. I'm an AI engineer at AstraZeneca, and we are scaling AI to accelerate drug discovery, like I was talking about, and doing a lot of healthcare innovations. But even within AstraZeneca, it's not just about processing more and more molecules or running bigger models. It's really about ensuring breakthroughs that can reach everyone who needs them, right, across geographies and all that kind of thing. So this is one of the programs that I'm very proud about. Healthy Hearts Africa. It's providing diagnostic tools in the continent to diagnose and do remote prescriptions and all these kind of things for heart-related and kidney diseases using AI. And this has been very successful. We're currently having validation in Kenya, Uganda, and Egypt. So to conclude, I think we have mastered to a large extent scaling AI across machines. And the next frontier for me, and I think it should be for a lot of people, is scaling AI across humanity. Thank you.
Thank you, Albert. And you were a bit over time, but very good. And in fact, it's very interesting, right? I mean, it's true that I think we have had a sequence of talks that have been kind of, starting, I would not say small by starting by robotics, but I would say with a clear focus. And then we have been kind of opening and going to humankind, which is, we cannot go wider than that. So thank you to all of you. And I would like to ask a question to Albert too. You're not going to leave without a question, right?
Thank you.
So, we've been talking about, I'm sorry, I'm supposed to be talking in Spanish, so I'm going to switch to Spanish. Perdonad.
I apologize for that. And I should have continued in Spanish and I forgot. So let me do this in Spanish because we will then continue with the conclusions and the goodbyes. We'll do that in Spanish. We've talked about many barriers, technological barriers, power, the fact that we need to protect ourselves, but on the other hand, we need to make sure that we reach everyone and everything. Access. AI should give solutions to all. And we can even wonder, to what extent do we want AI to do things for us? To what extent do we want to have this control that we've talked about, because the responsibility is still in our hands understood as the hands of the human race. So we want to continue to make decisions. Albert, I was wondering, what is the barrier we should be more worried about? Because everyone works on AI now. I have the feeling that whatever you do, you're doing it with AI nowadays. So which of these do you think could unlock this vision that you have of an AI that can reach everyone in their own language with relevant content that is of interest? Where is the main barrier to that?
I'm going to be a bit controversial on this, but I think for me, the main barrier is still around the people building the AI, right? Who are the people building the AI? Because that then reflects the kind of AI we're building, right? So we need to be, in my opinion, very careful and very intentional about the people we bring to the table to build the AI, right? If you're building AI for just say people age, if the people building AI are aged between 25 and let's say 35, right? You leave out a significant amount of the population that you're not even thinking about when you're doing these kind of things, right? We did the same thing when we built mobile phones, and then we rendered an entire population of elderly people completely incapable of doing things, right? Like even a simple thing as applying for a passport. If you have to do it online, and there was a generation that couldn't do it or didn't have the technical know-how to do it online, then that generation was completely locked out in a very small period of time. I feel like that's a barrier. Like we're not having enough representation in the type of people building the AI. Even if you look at the top models today, right? From ChatGPT to DeepSeek and all these top models, right? the representation is still very limited, right? It's still predominantly driven by big tech companies in the US and elsewhere. So we need to be a bit broader in terms of who is building the AI. And I think that's a limitation.
Perfecto. Pues me gustaría escuchar la voz sobre esto mismo y así
Wonderful.
vamos a terminar.
On this same topic, and with that we will conclude because it's almost 7, we have a few minutes. I wanted to ask the same question to the other speakers of today. Do you agree with Albert that maybe this is the greatest barrier that we need to work on? Those who are making the decisions, are they varied enough, diverse enough? And do we need to act on that? Or do you think that this is, or that there's another barrier that is limiting us more? So I will pass the floor over to you in the same order we spoke. First Maria, then Juanjo, then Irene, and with that we will conclude. And I would ask you to please give short answers. Maria, you go first. Great. I think this is a very good question, and it is true that the more diversity of opinion, viewpoints, perspectives as to how this impacts society from the different countries and persons, that's the best thing we can do. I think we have another problem right now if we think of AI in internet. It's difficult now to know to what extent we are basing ourselves on human-created information, AI-created information. So I think we need to start seeing how we regulate this, how we make sure that these models that will come in 10 years, I mean, 50% of the data should not come from another AI that published them 5 years ago. So I think there are many problems in terms of ethics and society that can have a great impact on us, and I think it's important to regulate this. And I think that those of us who are experts on this, well, I think we're trying to emphasize security aspects. At least in Google, this is something that's always on our minds. And I think now, in a way, there's a race as well who can build the best model quicker. And this has implications that are not always positive. And it's important that we're all aware of this. But I think for this to actually happen, we also need the involvement of more areas of society, not just the companies. I mean, the companies will build this, but we cannot expect the companies to do it all themselves. I think it would be better to look elsewhere as well. Thank you very much, Maria. Juanjo, what's your opinion on this? I think persons are key, but persons without a decision-making strategy and without adequate resources, they can do nothing. And I think that, especially thinking of Europe, the big issue we have is that the structure that we have as EU makes it very difficult to make large-scale decisions that will impact everyone the same way, not in a fraction manner, in a very swift manner with a lot of resources. We do not have those features. And even if you assign the right persons, I think it will be a very difficult task for them. And the second problem that I think impacts more the US is the business model. The investments to develop AI are huge. And the business model is basically exploiting data for advertising. And sometimes this clashes with trying to do the best for the patient. But having said this, I think we should be grateful to those big techs because they are sharing this technology. And we have many, many AI tools now available, open source. And I think we can do wonders in small scale with local groups. And the only thing preventing it is information and knowledge. But I think I'm very optimistic. Thank you so much, Juanjo. Irene, it's not 7 yet. What's your take on this? Perfect. I think it's a very important topic. I agree with the rest of the speakers. I think contribution of companies and stakeholders developing the tools, most of them open source, is critical. They have the resources, but I also think that we cannot miss this opportunity to democratize the development of AI in the field of medicine. This will change the way in which we do science. We do medicine in the future. It cannot be left in the hands, or we cannot have non-representative data in the hands of just a few stakeholders. We have the opportunity to rethink the future of science in a way that will reach everyone, and that will allow for open source initiatives, of course, with big developers, but not only that. It cannot be only that. We need structures that allow us to involve less represented populations and researchers and stakeholders who do not have so many resources. We need to include them, to have them participate in this race, because that's the only way in which the AI revolution will reach everyone and will be for everyone. Thank you so much, everyone. Thank you very much, Maria. Thank you very much, Juanjo. Thank you very much, Irene. Thank you very much, Albert. Thank you very much to the Becari's Association of the La Caixa Foundation and the Grants Program. And look at the conversation we have with just 4 members out of the more than 6,000. And imagine if not only the grant holders of La Caixa Foundation would join this conversation, but everyone else who should and have to benefit from AI. There's a lot to talk about. I'm sure we will need another knowledge day in the near future. But for now, I know there are questions that are unanswered. I'm sorry we're not able to answer them all, but we will bring them again to a future session. Let's continue the conversation here in Becari's Knowledge Day, in social media, and whenever we meet. Thank you all very much, and see you in the next Becari's Knowledge Day. Thank you.